Good morning. So we were in the middle of the deriving the rate of the work done by pressure force. So the question is whether this term is positive or negative, and what about this term. So to decide that, we have to consider the rate of work doing is force into velocity. So that is W equal to Fd cos theta. So the pressure is acting, for example for this, the pressure is acting in this direction, the pressure is acting in this direction, and the velocity is acting in this direction. So work is Fd cos theta. So P into U and theta both are in the same direction, so theta is 0. So cos theta is cos 0 is 1, that means it is positive plus 1. For example, here the pressure is acting in this direction, but the velocity is acting, this is the pressure which is acting, pressure force is acting in this direction, and the velocity is acting in this direction. So the angle between the two, theta is 180. So Fd cos theta, cos 180 is negative minus 1. So this term is positive because pressure and velocity are in the same direction. This term is positive because pressure and velocity are in the same direction, but on the other hand this term is going to be negative because pressure and velocity are in opposite direction. This term is negative because pressure and velocity are in the opposite direction. So you are going to this term will get cancelled out with this term will get cancelled out with this term. So we are left with del up by del x plus del vp by del y into dx dy dz. Okay. So that is about the rate of work done by the pressure force. Similarly, so we need to consider the normal stresses. So what are the normal stresses? These are the normal stresses. So here the normal stresses we are going to consider are sigma xx and sigma yy. So if we consider that sigma xx and sigma yy, what will be the rate of the work done by these normal stresses is what we are going to be concerned about. Okay. So we shall write that here, that is rate of work done by normal stresses. That is, you have again a parallelepiped, and as you recall, normal stresses we consider it as outward. Pressure always acts inwards, normal stresses are considered as outward. So you get sigma xx into force, that is dy dz, this is dx dy dz, this is the force, into velocity u, and this one is sigma xx dy dz into velocity u plus dou of sigma xx u into sigma xx divided by dou x into dx dy dz. Similarly, sigma yy dx dz, this is the force, into velocity v. Now at a distance dy above, you have sigma yy dx dz into v plus dou by dou y of v into sigma yy into dy into dx dz. Now again, using the same fundamental idea that sigma xx is in this direction, but u is in this direction, so theta is 180, so this becomes negative. So here again sigma yy is in this direction, v is in this direction. So, this is theta is 180. So, this becomes negative. Okay. So, you have this term negative, this term negative. Here in this case, sigma xx is in this direction, u is acting in this direction, theta is 0. So, cos 0 is positive. Okay. So, this term would be positive and this term would be positive. So, this gets cancelled out with this when you add, and this term gets cancelled out with this term. So, you are left with dou of u sigma xx by dou x plus dou of v sigma yy by dou y into dx dy dz. So, this is the rate of the work done by the normal stresses. Now, we need to take up the rate of work done by shear stresses, rate of work done by shear stress, by shear stress. So, again we consider parallelepiped, but this time we will be taking the shear stresses. So, you have sigma, this is sigma yx into dx dz into velocity u, okay, and this term, okay, these are shear stresses. So, one is in the left hand side and the other one is the right hand side. So, you have sigma yx into u into dx dz plus dou of sigma yx u by dou y into dy dx dz. Now, you have these two terms, one is in the top and the other one is the bottom. So, you have sigma xy into dy dz and it is acting velocity v, and here sigma xy into v dy dz plus dou of sigma xy into v divided by dou x into dx dy dz. Okay. So, now this here sigma xy is in the downward direction and the velocity is in the upward direction. So, theta is 180. So, cos 180 is negative, So, that means this term is going to be negative. Okay. Similarly, this term also will become negative because sigma xy, sigma yx is in this direction, u is in this direction. So, you have theta equal to 180. On the other hand, here sigma xy is in this direction and v is also in this direction. So, theta is 0. So, cos 0 is plus 1. So, this will become positive and this will become positive. So, if you add this term and this term gets cancelled out, this term and this term gets cancelled out. So, you are left with dou of sigma xy v by dou x plus sigma dou of sigma yx u by dou y into dx dy dz. So, this is the rate of the work done by the shear stresses. Now, we are ready to go to combine everything. So, if you recall, so what we had here is that we did the rate of the work done by the normal stresses. Now, we did the rate of the work done by the shear stresses. Now, we can combine all of them by putting the rate of the E increase in E in CV, and this term we have gotten conduction term, and we have gotten the work done by the surface forces, and of course for the body force you can just take it as Ufx plus Vfy. Okay, so if we combine all of this and write the equation, so what is that I get? That is rho d by dt, this is the left hand side if you recall, E plus U squared plus V squared by 2. Where did I get this? That is here. So you have this one, rho d by dt of E plus U squared plus V squared by 2. This term I have written. Now conduction term is k dou squared T by dou x squared by dou y squared is equal to k into dou squared T by dou x squared plus dou squared T by dou y squared minus of dou of up by dou x plus dou of vp by dou y plus dou of u sigma xx by dou x plus dou of v sigma yy by dou y. Just let me remind you, this is what we just derived a little while ago. This is because of the pressure force term, this term I wrote, and this term I wrote. Now this is because of the normal stresses, this term is because of the shear stresses. So this term if we write, that is plus dou of v sigma xy by dou x plus dou u sigma yx by dou y plus ufx, that is the work done because of the body force in the x direction. This is the body force in the y direction, v into fy plus q dot triple prime. So if there is any energy generation within my control volume, some chemical reaction took place, that heat has gotten added, some exothermic reaction has taken place, that has to be added, that can be added here, or anything has occurred by radiation, through flame, there is a flame inside, and by radiation the flame is giving heat transfer into my control volume, that can be put here. Or there can be a heater within my control volume and that heater is adding continuous heat, Vi heat, that can be added here. So this is the term, these are the terms which we have gotten added. Okay, so this, if we expand this, so we will write this as rho d by dt of E plus U squared plus V squared by 2 is equal to k into dou squared T by dou x squared plus dou squared T by dou y squared minus of, if I expand this, minus p into dou u by dou x plus dou v by dou y. That is, first you keep p as constant and differentiate here, p as constant, differentiate here. Now you take minus of u into dou p by dou x plus v dou p by dou y. So 4 terms you should get when you differentiate this, that is what we have gotten here. Plus similarly plus u dou sigma xx by dou x plus sigma xx dou u by dou x plus v dou sigma yy by dou y plus sigma yy into dou v by dou y, that completes this, plus now I am expanding this term, plus sigma xy into dou v by dou x plus v into sigma dou sigma xy by dou x plus u into sigma yx by dou y plus sigma yx into dou u by dou y. Okay, these are the velocity terms which you get by expanding that. So then you have ufx plus vfy plus q dot triple prime. This is a huge equation. So be it, we need to get this. See, there are various things here. Still this is energy term, still strain rate, these are stresses, we have to put them in terms of gradients and this energy term, and we have to find finally the temperature has to look has to appear in this energy equation. So let us call this as equation A. We need to do some algebra to get this in terms of temperature. So to do that, so what do we do is, before that we take up what is called, we had derived x momentum equation, we need to do some algebra. So let us do it little patiently. So x momentum equation, you have rho du by dt is equal to minus dou p by dou x plus dou sigma xx by dou x plus dou sigma yx by dou y plus fx. So if you multiply with velocity u, that is rho u du by dt, multiply with velocity u. So you can, this can be written as rho into d by dt of u squared by 2. If you differentiate this, you are going to get back this. So you get u into minus u into dou p by dou x plus u into dou sigma xx by dou x plus u into dou sigma yx by dou y plus u into f of x. And if you do the same thing for the y momentum equation, rho v dv by dt is equal to rho d of v squared by 2 divided by dt, you get minus v into dou p by dou y plus v into dou sigma xy by dou x plus v into dou sigma yy by dou y plus v into fy. So if you add these two terms, rho d of u squared by 2 plus v squared by 2, that is the left hand side, divided by dt is equal to minus u dou p by dou x plus u dou sigma xx by dou x plus u dou sigma yx by dou y plus u fx minus v dou p by dou y plus v into dou sigma xy by dou x plus v into dou sigma yy by dou y plus vfy. So this, let me call this as equation B. So if I do A minus B, this is equation A we had gotten, and now this is the equation B we got. So if I deduct A minus B, so this is your equation A and this is your equation B. Instead of rewriting in the write up, I can take this. You can see that many of the terms get cancelled out. For example, u del p by del x, u del p by del x, v del p by del y, v del p by del y, u del sigma xx by del x, u del sigma xx by del x, u del sigma yx by del y, u sigma del yx by del y. So these get cancelled out. And the interesting thing is that on the left hand side you have e plus u squared by 2, and here you have d u squared v squared by 2, u squared by 2 plus v squared by 2. So this and this get cancelled out. So you have, vanish, and you are left with rho de by dt. So let us write down the left out terms, that is rho de by dt, rho de by dt equal to k into dou squared t by dou x squared plus dou squared t by dou y squared minus of p into del u by del x plus del v by del y plus sigma xx del u by del x plus sigma yy del v by del y plus sigma xy del v by del x plus sigma yx del u by del y plus q dot triple prime. So now is the time to substitute sigma xx, sigma xy and the E term. So sigma xx is, we know in the momentum equation we took it as 2 mu del u by del x plus minus of 2 by 3 mu of del u by del x plus del v by del y, and sigma xy equal to sigma yx equal to mu into del u by del y plus del v by del x, and sigma yy is equal to 2 into mu into del v by del y minus 2 by 3 mu into del u by del x plus del v by del y, del v by del y. So if you substitute this, so if I substitute this, that is this term, if I substitute into this term, so I get what is called phi. That phi will be equal to 2 mu del u by del x whole squared, because this del u by del x is there and this del u by del x is there. So you get del u by del x whole squared, 2 mu del u by del x whole squared plus 2 mu del v by del y whole squared minus of 2 by 3 mu into del u by del x plus del v by del y whole squared minus plus mu into del u by del y plus del v by del x whole square. This is a small algebra to get this, which I have not done. Please, I would request, that is, just substitute this sigma xx here, sigma yy here and sigma xy, sigma yx here. You are going to get this. So what you get, I am calling that as phi, which we are going to call that as viscous dissipation term. So you get rho dou E by dou T, rho dE by dt equal to K into del squared T by del x squared plus del squared T by del y squared minus P of del u by del x plus del v by del y plus phi plus q dot triple prime. Okay. Still we have not arrived. Now let us try to get this. This is my equation. So now H equal to E plus P by rho. So if I take total derivative of this, dH by dt is equal to dE by dt plus 1 by rho, rho you keep constant and differentiate with respect to P, differentiate P with respect to T, and then you have rho, you differentiate rho, that is P 1 by rho if you differentiate minus 1 by rho squared d rho by dt. But by continuity equation you remember that d rho by dt plus rho del dot v is equal to 0. This is continuity equation. So I can write d rho by dt equal to minus rho into del u by del x plus del v by del y. So, if I substitute that, dH by dt equal to dE by dt plus 1 by rho d rho by dP by dt minus P by rho squared into minus rho into dou u by dou x. For d rho by dou t, I am substituting from here, dou v by dou y. So, you get this as dE by dt plus 1 by rho dP by dt plus P by rho into del u by del x plus del v by del y, that is dH by dt. But I do not want dH by dt, I want equation for dE by dt in my energy equation. So, dE by dt equal to dH by dt minus of 1 by rho dP by dt minus P by rho into del u by del x plus del v by del y. Okay. This has to be substituted in my energy equation, which was rho dou. This is the equation which I have to substitute. If I substitute here, my equation is, if I just recall, my equation is rho dE by dt equal to k into del square t by del x squared plus del square t by del y squared minus of P del u by del x plus del v by del y plus phi plus q dot triple prime. So, substitute for dE by dt from this equation. So, if I substitute into this equation, so I get rho into dH by dt minus 1 by rho dP by dt minus dP by dt minus P by rho del u by del x plus del v by del y is equal to k into del square t by del x squared plus del square t by del y squared minus of P into dou u by dou x plus dou v by dou y plus phi plus q dot triple prime. So, what happens here is that, this term rho into P by rho dou u by dou x and this term gets cancelled out. So, I am left with rho dH by dt is equal to k into dou squared t by dou x squared plus dou squared t by dou y squared plus this term, that is dP by dt plus phi plus q dot triple prime. We are almost there. We have to just substitute that H equal to Cp into T. So, that we shall do in the next class, that is, we shall substitute H is equal to Cp into T into this equation and we will get the energy equation. So, we shall derive the energy equation and get the physical significance of each of the terms and get to what is called as similarity variables. Thank you.